Chapter 9 Digital Coding. The objectives of this chapter is to design and test circuits that compare binary inputs, that convert between decimal and BCD, and that switch between multiple serial lines. In our first circuit, we'll be looking at a discrete 2-bit comparator that has 4 inputs and 1 output. The output goes high when D0 equals D1 and D2 equals D3. We set it into typical mode with setting flip-flops to 0, and we run the system. Selecting the nodes we want, D0, D1, D2, D3, and out. And we can see that it holds true. The output goes high when D0 equals D1 and D2 equals D3. In the second circuit of the chapter, a integrated 2-bit comparator uses a 7485. The 7485 compares the 4-bit values of the A and B inputs and activates the appropriate output line, whether it be A is less than B, A is equal to B, or A is greater than B. We run it the same way. And select the same traces with the 3 outputs. And on the far right, it is seen that the output does change the way it's supposed to. In the third circuit of the chapter, a 2-bit discrete decoder/encoder, we have on the left side with the inverters and the AND gates a BCD to decimal decoder, and on the right side with the 7432s the encoder, which takes the decimal value and changes it back to BCD. And the reason why the 0 output line of the decoder has no connection between the encoder output is automatically 0 when all the remaining decoder outputs are 0. It's a set default. Now we run the circuit. And select the 2 inputs and 0, 1, 2, 3, out 0 and out 1 for the outputs. And we can count the 0, 1, 2, 3 and see its equivalent in BCD value. And in the fourth circuit, the integrated decoder and encoder uses a 7442, which is a decoder, and a 74147, which is an encoder. It's the same principle, just using different chips, and for 10 numbers instead of 4. So you have 4 input lines, and into the decoder, 10 output lines out of the decoder into the encoder, back to 4 outputs to the BCD. And both these chips are active low, and we run the circuit for 12 microseconds, setting the step size to 12 nanoseconds, checking that it's at typical timing mode, and we run the circuit. And selecting the traces. Now we can see exactly through the cursors what value went in through the first 4 nodes, what comes out of the decoder to the next 10, which is its decimal value, and then converting it back in the last 4 nodes to its original value in BCD. Notice the last 4 nodes have switched from the top 4 nodes. This is because of the active low on the encoder, which inverts it.